So the format of the unit exam, before I even get into what's going to be on it, the format is this. There will be some multiple choice, not that many, like 20, 21, something like that, okay? And then there'll be some problem solving, some written response stuff, okay, at the end. The written response is worth way more than the multiple choice, okay? The multiple choice mostly tests like very simple calculations, some simple recall of like terminology and concepts, okay? And there's, you know, maybe a couple of graphs on there that are more like interpret this graph, or what is this graph saying, as opposed to calculate something from this graph. So it's simple stuff. The multiple choice questions generally are pretty fast. You should be able to do like 2 or 3 for sure per minute, okay? Like they really shouldn't take you that long. The written response, that's where you demonstrate your knowledge to me more. Okay, that's where you say, oh, I understand that this is this kind of a problem. I understand how to do it. Here's the steps. I show them to Mr. Coder. I get the answer right. I get my marks. All right. So that's obviously the more important part, but it's also the more time-consuming part of the test. Okay. Now, I have the test finished, and I've built the key. Okay. What I do to determine whether a test is easy, hard, or somewhere in the middle is I do the test, I make up the key, and I time myself. Okay, now because I make up the test, and well, I've done this a lot, I figure I should be able to do the test between 3 and 4 times as fast as you. Okay, I timed myself on this test. It took me 18 minutes. Okay, that means you have 85 minutes to write it. That's more than 4 times as long as it took me. Okay, generally that should mean it shouldn't be like super challenging for you to finish it in the time provided. Okay, had it taken me 25 or 26 minutes, then I probably would have gone, this test is too long. Okay, and I probably would have either changed the question or just taken a question off. This took me 18 minutes. Okay, so that means it should be well within your ability to complete it in the time allotted. That said, you don't want to dawdle. Okay, how long should you look at a question before you move on to something else? Like if I read a question and I'm not sure what to do, how long should I sit there and stare at it? 30 seconds. Okay, you read a question, within 30 seconds you can't identify what type of problem it is or how to start it, move on. Okay, move on to something else. Start the next question. In fact, my recommendation is read the test over before you do anything. Not the multiple choice, but the written response for sure. Okay, and what I would say you should do is rank them. I know how to do that one. I'm going to do it first. I know how to do that one. I'm going to do it second. Okay, do the ones you know how to do first. Why? Exactly. Okay, why not get the ones done that you're sure about? Okay, there's nothing worse than sitting there staring at a question you can't do and have it prevent you from showing me what you can do. Okay, if at the end of the test that question is still not done, so be it. At least the other ones are. Okay, but I have seen people who will literally sit and stare at the first question on the test when they're fully capable of doing all the others and not get the others done. Okay, which is like the worst time management possible on a test. Okay, so my recommendation is read it over and know I can do this one, and this one. Okay, I'm going to do those 3. Right, that way you've got them done. You know you're getting your marks for those. And 2 other things usually happen. Well, 1 definitely happens. You feel good about yourself because you got those 3 questions done. Your confidence comes back and like, yeah, I know how to do this, and feel good. Okay. And the other thing is sometimes they remind you of, oh, right, I can use that formula on that question I didn't know how to do when I first read it. Now I know how to do that question. Okay, doing other questions will sometimes trigger something in your memory, okay, that allows you to do those ones as well. All right, so that's my recommendation in terms of test-taking strategy for physics. Okay, I would say do the written response first and leave the multiple choice for the end. The formulas are on the front of the test, okay, because I don't know how much stuff you've written on your formula sheet. Okay, so what you will have on the front of your formula sheet is basically this part of the formula, or sorry, on the front of your exam will be this part of your formula sheet, because that's all you need for this test. Okay, each progressive test there'll be more and more on there. Till the final exam, you basically get a new one of these. Okay. But no, you can't use your formula sheet. But no, you don't have to memorize the formulas either. There's no point in that, right? Like even on the diploma exam, you get a data booklet, right? So we're not going to make you memorize the formulas. Okay. All right. So that's format. Any questions on format? Okay, I'll be more specific about what's on the test in a little bit here. Okay, so the first thing we went over in this unit was we reviewed scalars and vectors from Science 10. Okay, so is it possible you could get a really easy multiple choice question that says which of the following is a scalar quantity? Yeah, it's possible. Okay, that's a pretty easy question. You'd have to know which things are scalar and which things are vector, but obviously that's not going to count for a huge number of marks on the test. Okay, the reason you need to know scalars and vectors is for the written response. You got a big long problem that starts out something like, somebody drops something off a building. It falls, 200 meters. What's its final velocity? Am I looking for a scalar quantity or a vector quantity? I'm looking for a vector quantity. I got to remember that number needs down on it when I'm finished. Okay, that's where you need to remember it. You'd be surprised how many people lose a mark because they do the whole thing right and then forget to put a vector on the end. Okay, so that's the main reason we need to know our scalars and vectors. So what we talked about was this. Okay, scalar quantities, time, distance, speed. Energy and work aren't part of this unit, but they're also scalar quantities. Okay, displacement, velocity, and acceleration are our vector quantities in this unit. Okay, so we need to remember that because in some cases, like especially if we're doing some calculations from a graph, we may solve for displacement and distance differently because one is scalar and one is vector. All right, and at that same time, we reviewed V equals d over t, okay, where V can be velocity equals displacement over time, or V equals d over t can mean speed is distance over time, right? And this would be total distance over total time, total displacement over total time. Okay, are you going to get a 5-mark problem-solving problem about a V equals d over t question? No. Okay. But do we have some other problems where V equals d over t comes in? Yeah, like projectile motion. Okay, got to be able to use it for that. All right, so it's certainly a formula you're going to have to be able to use. It could be part of a multiple choice question. It's a simple calculation. Okay, so it could be in the multiple choice. All right, the second thing we talked about, graphing. Graphing's huge. Okay, it's huge. There are, I think, 3 graphs in the multiple choice. They're mostly interpretation or simple calculations. And there's both kinds of graphs in the written. There's one question that's position versus time. There's one question that's velocity versus time. Right? So what am I going to ask you, do you suppose? This is always the question you want to ask yourself when you're studying, but I'll ask it for you. What am I going to ask you to do with a position versus time graph? Probably ask you to find the velocity, okay? If I give you the graph and it's just linear, what else will I give you? Oh, not acceleration. I'll give you the equation. Should you know how to use it? Should you know what each part of it represents? Yeah. Okay. And the same would go for velocity versus time, right? I mean, if I'm going to give you both kinds of graphs, okay, you don't know whether one of them will be linear and one will be, kind of all over the place, but you got to be able to do your basic graphing skills, okay, which is use y equals mx plus b or things like that. Now, when we were talking about the 2 labs, okay, and the labs are crucial here, I'm going to ask you to do exactly the same things on the test that I asked you to do on the labs in the analysis. I only see a couple of people writing that down, but I just told you what I'm going to ask you to do on the exam to do with those 2 graphs. And it's exactly what I asked you to do in the analysis of the 2 labs. Nothing different. Those are the skills you have to demonstrate to me. So should we look over our labs? Definitely. Okay. If that was something we didn't get right, might be something to come in and ask about. Okay. So there's definitely going to be some calculating there's definitely going to be some interpretation to do with both kinds of graphs. Okay, and again, I'm going to ask you the same things I asked you to do before. Okay, calculate the displacement from a position time graph. Calculate the displacement from a velocity versus time graph. Okay, you know, what's the acceleration? What's the velocity? What's the total distance traveled or whatever? Okay, I can ask all of those things because they're things that I asked you to do before. Read the question carefully. If it says, using your graph, what should you do? Right, use your graph, okay? Make sure you do it that way. Don't try and use a formula where you're picking one number or something like that. Use the graph, okay? All right, so for position versus time, okay, and velocity versus time, right, and I drew in here kind of an example graph. It's a little bit messy, right? But if I got a velocity versus time graph, okay, so my y equals mx plus b came out to 1.5 times x plus 3.4. Okay, then what I'm looking at here is, here's my graph. Could I calculate the area underneath the line? Yeah, okay. I might have to calculate what this number is so that I know the height of my triangle, but okay, I can do that calculation. It's exactly the same calculation I asked you to do on your lab. All right, calculate that area. If it's a position versus time graph, well, total displacement's final position minus initial position. I can get those off the graph, or I can calculate them using the graphing equation or whatever. Okay, the graphs will be nice and clear. You'll be able to read everything off of them that you need. Right? But again, same ideas. You're going to be asked to use y equals mx plus b, okay, for at least one of the graphs. All right, and one of the graphs will probably not be linear, okay, and you'll have to do some other stuff with it. Right, but expect that one graph will require y equals mx plus b and one won't. Okay, one will require something else. Okay, questions there? All right. After we talked about graphs, because we went from velocity versus time graphs straight to acceleration, okay, because it was kind of a natural transition. You had to calculate acceleration from those graphs anyway. Okay. So expect that there'll be some problem solving to do with acceleration. Okay. In like a simple problem to solve in the multiple choice and a more detailed one in the written response. And is acceleration part of projectile motion? Yeah. So knowing how to use our acceleration formulas, manipulate them, calculate stuff with them is pretty important. It's going to be part of many of the marks and questions on your test. Okay. Okay, vector addition. There's 2 written response questions on vector addition. There are a significant number of marks as well. Okay, now I've told you time and again, a vector component addition question on your unit exam is going to involve one vector that is either vertical or horizontal and one that is angled. Calculate the components, find the resultants. Okay, I'm not trying to trick you. All right, I just need to know that you can do those. You can demonstrate that skill. Okay, the other vector question, okay, could be, you know, another type that we've gone over. Okay, and we've gone over lots of different kinds. We've gone over like the boat questions and the plane questions and things like that. Okay, so you're going to have 2 vector addition problems. One will be vector component addition, and the other is going to be some other kind of vector problem. Okay, so just to review, okay, we always draw them tail to head. Okay, including if it was a boat or a plane or something like that. Okay, we still draw them that way. And remember that if it is a boat question, there's a couple of things to be mindful of. Rowing across looks like that with the current. Okay, wanting to go across looks like this. That's the rowing. That's the current. You end up going across. Okay, rowing across means you head across but don't end up straight across, right? The other thing to be mindful of, and this is true on your vector assignment as well, is pay attention to where the question asks the angle to be measured from. Okay, because sometimes we overlook that. We kind of get done the question like, sweet, I got it all done, huh? And then we forget the last part of the question that said, what is the angle relative to this? Most of the time, it's going to say relative to the shore. That's this angle. That's measured from the shore. Okay, but it's very easy to calculate this one inside, right? If I calculate that one inside, all I need to do is what to get this one? 90 minus, right? I'm just looking for the other half. Okay, so just make sure that if read the question carefully, make sure it doesn't or does say measured from here, right? Or maybe it just asked for a certain vector. Maybe it says it's north across the river. Okay, then your angle would be east of north or whatever. Okay, just make sure you give the proper vector that it asks for. Okay, so your vector addition problem on your test would probably be between 6 and 8 marks. Okay, and then you'd have a second vector question, again, probably worth about the same. Okay, probably multi-step. Right, because we know with boat questions, it's not just about finding the resultant. Sometimes you're also asked to calculate how far downstream you would be, or what direction do you need to head in, or whatever. Okay. All right, and then after vector addition, we went to projectile motion. There's one of each type on the test, okay, in the problem solving. So there's a projected horizontally question, and there's a projected at an angle question, one of each. They are just like the ones we have done in class. Not the extreme ones, most of the ones we have done in class. Okay, again, sorry, I haven't told you this, but my philosophy on tests is a test is not the place for the hardest question I can think up. That's what assignments are for. Okay, I can put a really hard one on there because you got more time. Okay, on a test, I want to know, can you demonstrate that you've acquired the skills? That's it. I don't need the hardest question I can think up to test that. All right. Now, I'm not saying, hey, I just put the easiest questions on the test to be nice to you, because I didn't do that either. I'm not that nice. Okay, but okay, know that I didn't put any that are ridiculously unfair either. All right, so problem solving to do with projectile motion. Okay, okay. Multiple choice. You're going to get those zip grade forms. You guys use those before? Okay, they're awesome because we just take a picture of them. But here's the thing with the zip grade marking algorithm. The zip grade marking algorithm assumes you are only going to choose one answer in the multiple choice. So I do not want to see what I'm about to show you. Bring a pencil so that you can erase anything that you decide to change. If you do this in pen, you'll get this question wrong. Okay, so you're doing the question, you come to your answer, you're like, oh, it's totally B. And you shade that puppy in. And then you go back and read the question, oh, shoot. No, it's not B. It's actually D. Oh, no, 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 it's not. It's not that one. It's zip grade just says wrong. That's all it says. Okay. As soon as it sees more than one bubble filled in, it says wrong. Okay. That's it. So please don't do that. Okay. Bring a pencil and erase the ones that are not the one. Okay. Because I see this, okay, on people's multiple choice forms, and they think that for some reason I'm going to go back through and check all those ones. Because usually when I see this, it's like more than once on the same sheet. Okay. Because that person used pen even though I told them not to. All right, so I'm telling you, don't use pen. I'm not going back over your test. Okay, I'm taking a picture of it and I'm relying on the thing to take it right. Okay, don't do this. Use a pencil and eraser. All right. Here's the details about your test. 17 multiple choice questions. Okay. And the multiple choice questions are going to ask, scalar vector recall stuff. Okay. Simple scalar vector kind of calculations. Okay. Like, if I walk to Walmart and back, what's my displacement? Like, stuff like that. Okay. So several questions like that just are kind of just checking your understanding of terminology and things. Okay, and then some simple problem solving, like situational stuff, like read this question and then tell me something about it. Okay, then some interpretations of graphs. Okay, so there's two position versus time graphs in a row. Okay, where you're going to answer some questions that are simple calculations or interpretation of the graph. What's going on in the graph? Which line shows the object moving faster? Which, what part of the graph is showing the object at rest or whatever. Okay. And then a couple of things on just motion. Then there's a velocity versus time graph. So interpretation again, okay. Not really any calculating, just interpreting the velocity versus time graph. There's a couple of things on just principles of vectors, not any calculating, but principles of how vectors are drawn and things like that. And then there's 3 questions about the principles of projectile motion. Okay, again, not any calculating, just about the principles of it. Okay, that's the multiple choice. Okay, for the written, and I've kind of already told you what's in the written, but I'll tell you again. Okay, the written is out of 48 marks. Okay, you got 17 multiple choice questions, 1 mark each for those. Then you got 48 marks in the written. So way, way more in the written. Okay, we got a projected horizontally projectile question. We have a projected at an angle question with 2 parts. We have a vector question with 2 parts. We have an acceleration problem. We have a graphing problem with 3 parts. A vector component addition problem. And then another graphing problem with 5 parts. Some are interpretation, some are calculating. And then there's a bonus question. Don't do it unless you have the whole test done. Okay? I don't know how many times I've seen people who are sitting there trying to get the bonus question, which is only out of 2 marks, and they leave a 6-mark question blank in order to do it. Don't do that. Okay? It's simple math. 6 is better than 2. Okay? All right. In regards to marks and calculations, if a question in the written response is out of 1 mark, how much calculating is there? None. There isn't any. Okay? If it's out of 1 mark, the answer is right in front of you. You wouldn't believe how much calculating I see on 1 mark questions. Okay? Like 6 marks worth of calculating to prove something that's not true when it was a 1 mark question that the answer was right in front of you. Okay, always look at what the question is out of. At the end of them, okay, so it'll be, the blurb, and then in brackets, how many marks? Okay, if it's out of 6 marks, there's a lot of work. If it's out of 1 mark, there isn't any. Okay, if it's out of 2 marks, it's probably a simple calculation with no manipulation. Okay, something like that. Just be mindful. Marks, the amount of marks a question is out of tells you a lot about the question. So if you're kind of lost on it and you're looking at it going, all right, I'm lost on this, it's worth 6 marks, that's not an ideal situation because there's a lot to do there. Okay, but if you're kind of lost on it and it's a 1 mark question, just look around. Okay, the answer's there. Okay, it's either oh, right, that's a flat line on a position time graph. That means it's stationary. Oh, right, it should be 0. Okay, or whatever. Okay, it's something simple like that. Okay. So hopefully that helps a little bit. Always look at what the question's out of. It can tell you a lot about the question. All right. Yeah, so the whole thing's out of 65 marks. Okay, 48 in the written, 17 in the multiple choice. Okay, questions from you guys? Anything you want clarified? I put the exam review package on yesterday. Okay, so there are some questions in there with the solution. So I put the key as well as the review part. So it's in there. Yes, you get it back next day, just like you always do. So, yeah, 11th Monday, right? Yeah. Yes. Yeah, we will. Okay. What else, guys? Anything you want me to cover again or talk about a little more? Okay. That you use, yeah. Okay. Any measured value, right, that is used in a calculation will affect your significant digits. And remember that going from part A to part B, you use your significant digit value. If you're using something you calculated in part A to solve for something in part B, it's the significant digits you ended with in part A that you use in part B. Okay. Is there anything that can just like trace? No, I don't think so. At least I don't remember, unless I fooled myself. I made the key, and I don't think that's the case. Sorry, say that again. The least amount. Right. Including angles. Angles are measured values. Okay. Any measured value affects your significant figures. Okay. Things that don't are counted numbers. Right. So if I don't know, like if you're watching a pendulum go back and forth and you count the swings, that's not measured. It's counted. Okay, so it would not affect your significant digits because there's no uncertainty. There was no uncertainty. Well, there's lots of uncertainty, but you don't know how much because you counted it. Okay, so it can't affect it. Okay. There's nothing like that on this test. Okay. There's no count. We don't really get into that until we get to the simple harmonic motion stuff. Okay, what else? Another example of both questions? Okay, of which, like going in or going? Oh, I have some graphing stuff on here. Maybe we can go over that after I do the boat question. Okay, all right, so boat question. Okay, so Okay, so the question you're talking about is something like this, okay? All right, so what we have here is the person is rowing directly north. Are they going directly north? No, they're rowing directly north. Okay, especially since the question actually asks, how far downstream will they be? I wouldn't ask that if they were going to end up going straight across the river, because the answer would be 0. All right, so in this case, they're rowing directly across at 2.0 meters per second. The current, and that's north, right? Because it says north on here, directly north across a river, so that's north. Okay, due east is the current, 0.75 meters per second. All right, so they want to know the resultant velocity of the boat relative to the shore. Okay, so that would be this shore here. So my resultant velocity is this side, but I want that angle, because that's the angle that's relative to the shore. Everyone follow me there? Okay. So to calculate the resultant velocity, I just do a Pythagorean theorem calculation. That'll get me V. Okay, so 2 squared plus 0.75 squared. All right, so it's 2.14. Actually, we only have 2 significant digits here, so 2.1. 2.1 meters per second is my resultant velocity, okay, going across the river. Sorry, my resultant speed. I still need the angle to have the resultant velocity. Okay, so I can either calculate this angle here and then go 90 minus, or I can flip the triangle. Okay, that's what I'm going to do because it'll take less time. All right, so we're going to have a second tan of 2 divided by 0.75. All right, so the angle is going to be 69 degrees north of east. Okay, or I could say relative to the shore. That would also be acceptable as a vector. Okay, so that's the first part. Now, the second part of the question wants to know, when they get to the other side, how far downstream will they be if the river is 50 meters wide? All right, so I want to calculate the D that goes along with this. All right, what I have is this. Which speed do I use to calculate how long it will take me to get across? Because I need that. Just like in a projectile motion question, I need time. I'd use 2. Okay, I can't use the 2.1 because it's further than 50 meters to go diagonally across the river. Okay, I mean, I could calculate what it is, but why would I do more work when I already have the number that goes along with the 2 meters per second? Okay, the answer is hopefully you wouldn't, because that takes time. Okay, so I've got 50 meters, so T equals D over V. Okay, 50 over 2 is going to give me that this takes 25 seconds. Okay, it's going to take me 25 seconds to get across the river. Okay. Oh, you wrote down 20. Yeah, it's 2.0. Okay, so now that I have that, okay, now that I have the time, I can use this velocity because I'm going downstream at 0.75 meters per second for 25 seconds. Okay, so if I take that 25 and I multiply it by the 0.75, I'm going to end up 18. Well, actually, we only have 2 significant figures. I'm going to end up 19 meters downstream when I get across the river. Okay, something that just occurred to me that I should remind you or make you aware of. When you're reading through a problem, make sure you look at the units carefully. In some of the problems on the unit exam, I might give you a velocity in meters per second, but give you a displacement in kilometers. Can you use those 2 numbers together? Not until you do what? Not until you convert one or the other. My suggestion would be convert the displacement one to meters. Okay. and you won't need it. I didn't make any questions where you have to convert kilometers per hour to meters per second. Okay? But I did make some where, you know, the displacement number was just really big, and I put it in kilometers just out of habit. So just be aware, because it's a silly mistake, right? Like you do everything right except you forget to convert kilometers to meters, and then you get a number that's way too small. Okay? No. There's 1,000 meters in a kilometer. Yeah.
Something says above the negative side of an x-axis.
Okay, so that's an XY scatter plot. Okay, so a standard XY scatter plot looks like this. This is the positive y-axis. This is the positive x-axis. This is the negative y-axis. This is the negative x-axis. Yeah?
But if it says 20 degrees above the negative side of the x-axis, you're assuming it's...
That means it's measured from the negative x-axis.
Which way?
Above. Above. Up. Positive. Yeah. Below would be negative. Yeah. Yeah. All right. Now, in terms of graphing, because there's lots of graphing. Okay. If I get a linear position versus time graph, okay, things to think about, things to remember. Okay. Here's my graphing equation, right? Google Sheets doesn't always spit it out with the y. So we got y equals 1.53 times x plus 3.23. Okay. A possible like 1 mark question for this graph could be, what was the initial position of the object? Right, 3.23 meters. Okay, and maybe on there it would say north or something like that. Okay, so you would say that. Right, that could be an example of a 1 mark kind of question. Or what's the velocity of this object? Yeah, 1.53 meters per second. Those are examples of like 1 mark problems. You just got to recognize it from the graph. Okay, they don't require any calculating. Now, a calculating question could be calculate the position of the object after 50 seconds. Okay, that's not on the graph, is it? The graph ends at 30. Can I still calculate it? Yeah, I solve for y, and I make x 50 seconds. Okay, so those are the kinds of things that you might be asked to do. Okay, they were exactly the same things you were asked to do on your position versus time graph lab. Okay, exactly those same things. All right, velocity versus time graph. Okay, we already kind of talked, I diagrammed this already. I might ask you to calculate the displacement between 0 and like 20 seconds. Okay, so if that's the case, okay, I would need to calculate what's the y value here. I would need to calculate the area of this, the area of that, okay, and get my answer. I've never heard of that formula. If there's an appropriate formula that you can use with numbers from the graph, or that you calculated from the graph, that would be fine. Okay, but I caution you against using a formula if you're pulling numbers that are not on your line, or they're just data numbers. Okay, because it could be that I give you a data chart and the graph, right?
Would you say that I did?
Of that point, I would calculate it. Right, 2.3 times 20 plus 4.63. That would tell me what that number is, right? Yep. All right, everybody follow me there? Okay, a 1 mark question off of this one could be, what's the acceleration of the object? 2.3 meters per second squared, slope of the line, remember? Okay, y minus b over x on this graph is vf minus vi over t. Okay, everybody with me there? Those are the things we got to understand. Those things we got to review, okay? Because they're the things that will be tested. They were on the graph, the labs that we did. All right, if I got a velocity versus time graph that looks like this, okay? Obviously, I'm not going to use y equals mx plus b here. Okay, that equation is not even on here. All right, but I could ask you something like, what's the acceleration between 0 and 20 seconds? All right, well, then you'd have to, get your numbers, okay, and do a calculation using a formula. In that case, it would be okay to use a formula because it's not linear. All right. I could ask you, probably I wouldn't on this because it would take you too long, but I could ask you what's the total displacement, right? It's a lot of areas to calculate, so I probably wouldn't do that, but okay, you get the idea. All right, position versus time graph. I could give you one like this and ask you something like, what is the object doing between 5 and 10 seconds? What's it doing there? Right, moving in a negative direction at a constant velocity. All right, I could ask you, what's the total distance traveled? Okay, so I'd have to figure out how far here, how far here, how far here, how far, add them all up. Okay, things like that. All the same kind of calculations that we did in class. Right. Oh yeah, I'll make the graph way better. Yeah, this was just, I threw these together so I would have them. Yeah, the ones on your test have lots of grid lines. So if you needed a number, you'd be able to read it, okay, or calculate it, one or the other. Okay. What else, guys? Okay, well, if there aren't any other questions, my suggestion to you would be have a look at the review package right now and see what kinds of things you might want to work on.
Question. What are the keywords to know if it's the boats are going at angles that it ends up directly?
Well, they want to end up straight across, or they want to end up going straight across, or they want to be across, something like that. Okay? If it says they're rowing across, they're not going across. Okay. All right, well, let's get to work on the review stuff there, guys. You got a bit of time here left, and we can talk about those if there's more questions. Emily? Yes, you can. Yeah. Okay. All right, so if I have this ball that rolls off of this incline, okay, on the top of a building, okay, then I'm going to have this situation here, okay, where my projected velocity, go away. Okay, where my projected velocity is 18 meters per second, right? That means that this side of the triangle is VI. It means this side of the triangle is V horizontal, okay? This is just like if I projected it upwards. The only thing that's different is now VF and VI are not the same, okay? Because it's not returning to the same elevation it was fired from or launched from. So vertically speaking, okay, I know acceleration is negative 9.81 meters per second squared. VI, I'm going to calculate exactly the same way I always do. It's the opposite side, sine of 30 times 18, which means it's negative 9 meters per second because it's downwards. Okay, it's starting off in a downward direction. Okay, so this question would be asking us to calculate the height of the building. Right? That's what it would ask you to calculate. And I would have told you that it could, how far from the base it landed. So we'll say horizontally, okay, that you knew it hits the ground 20 meters from the base of the building. Sorry. Here? Oh, because it's here, 30 degrees. Like, it's all the same, right? No. Well, actually, I did. I used it here. It's a similar triangle, right? It's this angle here. It's a similar triangle. Okay. All right. So I've got the horizontal distance, and I can calculate V horizontal, okay, by going cos of 30 times 18. All right. So 15.588 is my. What the heck? Way already. Okay, so 15.588 meters per second, right, is my projected speed here. Okay, or sorry, my horizontal speed, horizontal velocity. Now that I have that, what can I calculate? Time. All right, so that's my next calculation. T equals D over V, 20 over 15.588. All right, so it's going to be 1.28 seconds. All right, now I can calculate the height of the building using so that'll be 9 times 1.28 plus 1/2, sorry, negative 9 times negative 9.81 times 1.28 squared. Okay, and that'll give us the height of the building. So negative 9 times my answer plus 0.5 times negative 9.81 times my answer squared. All right, so the building is 20. We only have two significant figures here. It's 20 meters high. Okay. Wow. The odds of the height of the building and the distance it travels from the base are astronomical for those to be alike. Well, they're not exactly alike, I guess, but they're close. They're close. Well, actually, what I calculated is the vertical displacement. That's why it came out negative. All right, so I could write it as the vertical displacement is 9 meters or is 20 meters down, or I could say the height of the building is 20 meters. Either way would be correct to express.
Are we gonna have to draw this out? Like, find out what he's saying?
You will have to draw. Yeah, all I'm giving you is the context of the question. Yeah, you will have to put any drawings and vectors and stuff like that in yourself. Okay, what else, guys? All right. Well, if there's no more questions, my suggestion to you would be